A fingerprint left on a glass, a face captured by a camera, a single cell of skin recovered from a crime scene. Each of these, a unique signature no two alike, can place a person at a place, link them to an act, or clear them entirely. Welcome to Chapter 4 of Crime Science, Biometrics. In this chapter, we examine the science of identifying people through the traits that make each of us unique. Three technologies sit at the center of this field: fingerprint analysis, facial recognition, and DNA profiling. Together, they have transformed criminal investigation, border security, and the pursuit of justice. Biometrics is a systematic measurement and statistical analysis of physical and behavioral characteristics intrinsic to individuals. It rests on a simple but powerful premise that certain features of the human body are stable, measurable, and unique enough to distinguish one person from every other person on Earth. Fingerprint analysis is the oldest and most established of these methods. The arrangement of ridges, valleys, and minutiae on every fingertip is unique. Even identical twins who share the same genetic code develop distinct fingerprint patterns through a complex interplay of genetics, prenatal environment, and random events during fetal development. Once formed, these patterns remain unchanged throughout a person's life, a lifelong identifier written into the skin. The transformation of fingerprint analysis from a manual, labor-intensive process to a powerful investigative tool came with the automated fingerprint identification system. AFIS converts fingerprint images into digital records and stores them in vast databases. When a new print is submitted, the system compares its minutiae and ridge patterns against millions of stored records, generating potential matches within seconds. What once took weeks of human comparison now takes moments. Fingerprint databases extend beyond criminal investigations. They support employment background checks, security clearances, border crossings, and access to secure facilities. The persistent challenge is the quality of latent prints lifted from crime scenes. Surfaces vary, conditions vary, and prints are often partial or distorted. Modern imaging technology, image enhancement algorithms, and integration with other biometric methods help overcome these limits. Facial recognition represents the next generation of biometric identification. The rise of artificial intelligence applied to the human face. Sophisticated algorithms break a facial image into detailed data points, converting them into a mathematical representation called a facial template. This template is then cross-referenced against a database of known faces. The leap forward came with deep learning, particularly convolutional neural networks. These systems learn from millions of images, adapting to variations in age, gender, race, lighting, expression, and accessories. The result is fast, precise face matching at scale. Law enforcement agencies use facial recognition to analyze CCTV footage, social media images, and other visual sources, accelerating the identification of suspects and assisting in the search for missing persons. But facial recognition raises serious ethical and technical concerns. The widespread, often covert collection of facial images in public spaces threatens individual anonymity. More troubling, facial recognition algorithms have repeatedly demonstrated reduced accuracy when analyzing the features of people from certain ethnic backgrounds, genders, or age groups. This bias can produce misidentifications, and misidentifications in a law enforcement context can produce wrongful detentions. Addressing these concerns requires diverse training datasets, ongoing audits, transparent reporting, and clear regulatory standards. DNA profiling is widely considered the gold standard in forensic science. The human genome contains specific regions called short tandem repeats, or STRs, which vary in the number of repeated nucleotide sequences from person to person. By extracting DNA from a biological sample, amplifying these regions through polymerase chain reaction, and separating the resulting fragments by size, forensic scientists produce a distinct DNA profile, a genetic fingerprint as unique as the person it came from. The probability that two genetically unrelated individuals share an identical DNA profile is exceedingly low. That precision has transformed the criminal justice system DNA evidence connects suspects to crime scenes with unparalleled accuracy. It identifies victims. It exposes patterns of serial criminal behavior across jurisdictions. And critically, it has corrected wrongful convictions through post-conviction DNA analysis, exonerating individuals falsely accused of crimes they did not commit. DNA profiling also enables familial searching, where partial matches in a database suggest biological relatives, a technique that has solved cases where direct matches were unavailable. Rapid DNA analysis tools now enable on-site testing, dramatically reducing the time between sample collection and investigative leads. The combined impact of these three technologies is profound. Together, they enable the swift identification of suspects, the linking of seemingly unrelated cases, the exoneration of the wrongfully accused, and the strengthening of border security. When integrated with surveillance systems and law enforcement databases, biometrics create a powerful, interconnected investigative network. But the more powerful these technologies become, the more carefully they must be governed. Biometric data is among the most sensitive personal information in existence, capturing the physiological essence of who a person is. Unauthorized access, data breaches, and misuse all carry profound consequences. Algorithmic bias threatens fairness. The boundary between legitimate investigative use and overreach must be drawn through robust security protocols, comprehensive laws, transparent oversight, and informed consent. The future of biometrics and criminal science depends on a balance, harnessing extraordinary identification power while protecting the rights, privacy, and dignity of the individuals these systems are designed to identify. In our next chapter, we move from identifying criminals to defending against them in the digital realm as we explore cybersecurity tools.